Hey, welcome back. So we're actually still talking about bubble sort because there's one important optimization we haven't discussed. So there's a very specific scenario where if our data is almost sorted or if it's already sorted, it doesn't need to be bubble sorted, our bubble sort algorithm as it stands doesn't really treat it any differently. It still tries to sort every single item. So in this scenario where we're almost sorted, if I fast forward through this, okay, maybe this was a bit too long. Okay, we're almost there. Now we're sorted, right? So we get to the end, and as humans, we can see that we're done, but our code is actually going to keep going. And it's going to go to the end, no swaps are made, but then it goes again, and it tries to sort all of these up until here, then it goes again, tries to sort all of these to here, even though nothing is happening, it's just iterating over. So if we have a super long array, that's going to be a problem because it just takes up a lot of unnecessary time. So we can short circuit our code. All that we have to do is check. Last time through, did we make any swaps? If the answer is no, if we didn't swap anything, that means that we're done. Because if you didn't swap on the last time, you're not going to swap on the next time. So back in our code, what I'll do, I guess I'll make two versions. We're getting a lot of solutions going. If we, I guess I'll comment these out for now. I never know what the best way of doing this is because students like to have this different steps as I go, but I also don't like making these super long files because it can scare some people. But what we can do, if we call this right now with a nearly sorted array, like 8, 1, 2, 3, 4, 5, 6, 7, for example. So we're almost there, right? After the first pass, it's going to be sorted. 8 will be to the end. If we take a look right now, how many comparisons we're making roughly, let's run it now. We're making a ton because it was sorted at this point and we kept going without making any swaps a ton of times after that. So what I'll do is I'm going to make a variable. I'll call it no swaps. And no swaps is if it's true, that means there were no swaps and we're going to break out of the loop. So I could start with that down here, even though it's not defined. I could write if no swaps break. So that would get us out. Of course, we don't have no swaps defined. So up here, I'll do var no swaps like this. And then inside the loop, each time through, I'm going to set it to be true. We'll assume there's no swaps every time through. But then if we make a swap, which is right here, remember, we can set it to be no swaps equals false. Does that make sense? So as we go through, every time at the beginning, so let's say we start with this, no swaps starts at true, and then we make a swap right off the bat. 8 and 1, we swap. So now there's no chance of breaking out this time through. But then we finish the iteration, and 8 is now at the end. You could see like here, for example. Next time through, no swaps is true, and we never make a swap. This is never true, so we never set it to false, which means we get through all the way to the end one time afterwards. So we sort it all, then we iterate through no swap, no swap, no swap. Then we get done with it, and this is true now, if no swaps, and we break out. So now if we take a look at how many times this prints out with this line, you can see that we basically had to get it to the end, which was right here. This was our first time through. And then we went through one more time and we finished. And then that was it. We didn't keep going. And compare that to the previous versions where we went through, we got 8 to the end, and then we kept sorting over and over and over and over and over, many more passes. In this case, we shortened it significantly. And as the array grows, if it is nearly sorted, that makes a very big difference. Okay, so I just added a little comment. This is our next version that we optimized with the no swaps variable. Just a small change, but it really can save a lot of time.